Let's talk about NumPy, right? In normal Python, how do we store numbers? Normally, we can create an array using a Python list, right? This is a Python list, right? Normally, NumPy means numerical Python, okay? NumPy is used for fast calculations, arrays and matrices, data science, ML, image processing, right? NumPy is faster than normal Python lists because written in C uses contiguous memory. Simply remember, NumPy is equal to fast math than arrays, right? NumPy is used to perform fast and efficient numerical calculations using arrays instead of Python lists. Now, open terminal and type pip install NumPy to install NumPy, right? If you are using Anaconda, NumPy is already installed, okay? Now, import NumPy in your application by adding import keyword, right? Okay. Then import your library NumPy, right? Okay. Now NumPy is imported and ready to use, right? Normally NumPy is imported under the np alias, right? np is the alias of this, right? You can use any name for this, right? Instead of np, we can use num or anything, right? J likewise, okay? It's not the issue. But normally we use np, right? In a Python, alias are an alternate name for referring to the same thing, right? We should create an alias with the as keyword while importing, right? This is, you can see the as keyword, right? Okay. Now the NumPy package can be referred to as np instead of NumPy, okay? Using this attribute, we can find our NumPy version. Let's run it. This is my NumPy version, right? The version string is stored under version attribute, this attribute, okay? NumPy is library name, okay? Simply remember, np is short name for NumPy, okay? This is a normal Python list, okay? In NumPy, we call an array object an nd array. Using the array function, we can create an nd array object. How can we? Give the array name first. Equal to np dot call the array method, right? See, okay. Now you can insert your item into a list or tuple or any array like object into an array. I will use list, right? And insert the numbers. Likewise, right? This created a NumPy array. You can print this number set using print call num inside parenthesis, right? And run it. You can see your number list. See, yeah. Let's try type function. Right. Type. Built-in Python function tells us the type of the object passed to it as shown in this code. Num is a NumPy array. The type of array is ND array type, right? Let's run it. You can see array is a NumPy and type of array is ND array, right? Dimensions in arrays. A dimension in array is one level of array depth. It means nested arrays. Let's see. You can't see any tuple or list. It has a single element, right? If ND array has one element, it is called a zero-dimensional array, right? If the array function has one tuple or list, we call it a one-dimensional array, right? This is a one-dimensional array because the array function has only a tuple, right? One-dimensional array is like a row. In NumPy, a 2D array is exactly an array of arrays, right? When you create a 2D array, you will see two sets of square brackets like this. This is one set and this is the another set, right? Okay. Brackets at the start and end, right? It is the visual clue that you have two levels of depth, right? This is the two-dimensional array, right? You can see we have two square brackets at the start and the end. Okay. A 3D array is where we add a third layer of depth, creating a stack of grids, right? If a 2D array is like a single sheet of paper with rows and columns, a 3D array is like a stack of papers or a book, right? In a 3D array, you will see three sets of square brackets at the beginning, right? This is the 3D array, right? You can see three sets of square brackets, right? This represents three levels of nesting. This is the outer level. It represents the entire stack of book, right? According to that, this is the outer level, right? Okay. This is the middle level. It represents each individual page, right? According to that, this is the middle level, right? Okay. It is two-dimensional array, okay? This is inner level. It represents each row on that page, right? See, this is the inner level of this array, right? It is an one-dimensional array, right? Okay. Using ending attribute, we can find how many dimensions are in array. Let's run it. This is the 3-dimension array, right? Let's try this one. And run it. See, now this is a two-dimensional array, right? The next one is higher dimensional array, right? In this case, an array can have any number of dimensions, right? The ND-min parameter stands for minimum dimensions, right? This forces NumPy to wrap that list in enough layers to reach a depth of 5. When you run this code, the output will be 5, right? Because we have 5 dimensions, right? That's why it gives 5, right? Behind the scenes, NumPy adds extra square brackets to meet our requirement, right? If we were print the array itself, it would like this. See? This is a 5-dimensional array, right? If you get something from this video, don't forget to subscribe us, like, comment and share with your friends. Bye bye.